Hi, good morning. First of all, uh, most of you know me. Like I have worked with in CI&T for like 5 months. But my name is Priyanka Sindha. I am a software developer. Joined CI&T in December. So today I'm gonna give a brief introduction about the serverless and its agility and scale with the AWS Lambda. So first of all, before I start, right, let's go in the history, like what happened and like how we have evolved, like how technology has evolved from like managing a server or having like a running up shell scripts or running a small code of stuff in the server itself, and then we were doing like a file transition and everything. So how it has evolved from like having a traditional server based or in on premises servers, monitors and app servers, and it right now it's begun to have we have nothing to manage. We just run our code and it does everything by itself. So today's agenda, so this is edit we are gonna go through the history serverless first, and then AWS Lambda introduction. Then we are gonna see a couple of example of the building a Lambda function, and then understanding the architecture or understanding how it runs different things together without managing any of them. And lastly, we are gonna go through the question and answer. Next, before we go further in this topic, let's say, where does serverless come from? Serverless, like, does serverless means there is no server? No, it's not about that. It's actually serverless means you, as a developer or as a user, you don't have to manage anything about the infra or any, like any you don't have to think about the authentication, you don't have to think about maintenance release, you don't have to think about like how many servers I need for like scale up my or provide my high availability of the apps or any services or any batch processing or job queues. So let's go a little bit like a roll back to the like 14 years ago. So it all started from there. So 14 years ago we had like a couple of architectures, or you can say strategies, that defined of like different stuff. So first we had it like IaaS, like infrastructure as a services. What IaaS at that time had it's like, so your infra runs, so your infra handles everything, and then you run your functions, applications, runtimes, and the operating systems. So that was the infra. Only infra was provided by vendor. So if you go like 14 years ago, AWS, or like it wasn't present that time, but 14 years ago, let's say I had infra Oracle or IBM that was providing me infrastructure, and then companies were like just developing a function application, putting it on the infrastructure, and then running out, going like, okay, I don't have to manage that infra, I am going to pay it to vendor and they will manage it. Then slowly after the like a couple of years, it come like a product as a platform as a services, which does has it like a runtime, a operating system and infra together provided by vendor. And then all the developers or organization do is just building a running a code, building a functions or application and put it on the services. Then again, then after the pass, it provide like next thing comes as, which is our basic fundamentals of the serverless computing, is function services. What do you mean by run by function as a services? That it doesn't have to, you have to just build the code, you don't have to think about like anything else. You don't do maintenance, you don't do administrations, or you don't do authentication. You don't have to scale up or think about, okay, like today I'm gonna hit up the 1,000 requests. Tomorrow if my user increases, I have to scale up my servers to like 2,000 requests, then after a month like 5,000. So before it has to like, okay, you go to vendor, adds up this extra server or app server or any database server, or scale up those stuff by manually doing a maintenance. I have a very good example that like, so in like 5 years back, like there is like Informatica was there. It's a big data tool. So when you do Informatica maintenance, it does take like 7 months to update, because you have to update your app server with the a compatible Informatica version. Then you have, if you have a Java services, then you have to update your JBoss services servers to compatible with the Informatica, what version you are going to upgrade. That was a like little bit, kind of a hustle for it. So that this, to overcome this kind of stuff, currently in a current time, it all provided by serverless. So serverless, or you can say it's a fundamental based on the function as a services. So all you do, or all companies does, is just develop a function and deploy on us infra, and you don't have to wait for anything. That is where this whole serverless computing meaning or came from. Like, how, like I don't want to do anything. I just deploy everything and just run my function. It does scale up or do its running environment authentications or administrations by itself. All you need to do whenever you use the extra resources, it just you have to pay as you go. So that is what serverless came from. And then what is serverless means? Then it's serverless is the way to describe a services, practices, or strategies, or enable to developer to build more agile application that they can innovate and respond to change faster. Let's say I have a change today, which I need to deploy like next couple of sprint or even next sprint. Then you can deploy. You don't you there is you do you are not gonna have a story, or you're not gonna have a story for infra cards. Once you set up, it's done. You have to just deploy, add your business logics into it, add your features into it, and you just continue those management task, infra management task, or operational task, or uh, any of the task related to infrastructure, or managing your resources like app server, or uh, any of the other servers like a DB or anything. Those are completely go away. You just need to focus on writing a codes and serve your customers. What is the next thing? There are many providers out there. Like, if the major providers are like AWS, Azure, Google, IBM, and there is other vendors too. But the majorly, those four has evolved more. And specifically, if I can say, it has more feature in the AWS Lambda, which is developed by Amazon. It's a major key player, and it gives you so much resources and the freedom from those maintenance tasks, or uh, patching, or the other resource. The AWS provides AWS provides the AWS Lambda as an serverless computing. Google has a GCF. It's a Google Functions. So it provides the same. It serves the same fundamentals. Azure has Azure Functions, and IBM has its own functions running on the same structure. Next, uh, this is one of the quote I really like it. It's like, no server is easier to manage than number of servers. Like, it's given by the CTO of the Amazon, but I really like it, because you don't have to worry about the number of servers. You don't have to about the scale up thing. You don't have to about runtime, what my example looks like, what my code is gonna look like. You just need to build your code and just worrying about nothing. Currently, there are like in a market, there are like this, all four major vendors has like a bigger competition ongoing. Like, they are competing, like, which can provide more services to it. But AW has couple of stuff, like most of them, like it provides you a compute console, or you can use the Visual Studio Code. It provides you application integrations. It provides you a database. It provides you a edge computing as well. So basically, a the AWS provides the first of the compute is like AWS Lambda and the AWS Fargate. That these two technology actually based like computes your code. You can either use AWS Console, Lambda Console to compute it, or you can use Visual Studio or Visual Studio Code to compute your. If you are building AWS Lambda based on the different technology, different languages, like let's say there are a couple of languages available. One is majorly and we are going to use today is the C#, and the other one is a Node.js, Java, Go, and Python. It offers those 5 languages to run building a core AWS Lambda functions and serverless functions. And then the integrations applications are like if you can integrate your AWS Lambda function. Doesn't matter which language it's developed or have a code in it. You can integrate with S3, which is a simple storage system, S3 bucket. And then it has the Amazon SQS. Then it's the Amazon SNS. You can integrate AppSync. You can integrate with this all technology and have it your function running based on the triggers or function running based on the APIs or RESTful APIs, or you can just run HTTP APIs. Then function, like you can trigger a function based on your CloudWatch notification. Let's say I have a log, like I wanted to trigger my Lambda function once I have a specific type of log. Then this is one of the use case scenario, or there is another use case scenario. I wanted to run my function when I have active log or active AppSync status of the specific job or specific processing. So those all are integrated by itself. All you have to do, or all we as a developer we have to do, is like create your code, have a provided like a services, like a resources, mention it, and then deploy it. That's it. You are done with the deployment, and then it will run by its own. You don't have to in the future, let's say currently my application has only just a 5 user. It just hits in a week it has only like 200 requests. But when your application goes out, like okay, now I'm going to have a more users, then it scale up by itself. You don't have to worry about. So it has like whenever the Lambda function executes, it starts running, initiating the instances. So when the instance is initiated, it does like a specific request, like 5 requests. It's just a one instance or anything. And then next day you have like a 10 request or 100 requests. Then it has like more instance to scale up that your availability of the app. So that way you don't need to, as a developer, don't need to worry about, or as a customer or user of it, you don't need to worry about scaling your application or availability of the applications or anything. Like it has a concurrency reserved as well. So whenever there is it hits the concurrency, reserved concurrency, it adds that latency by itself. You don't have to worry about that your concurrency level hit and I need to like do some task, or I need to open a ticket or something like that. So let's go deeper down in the next one. Wins of serverless. What are the wins of serverless? First of all, like what are the pros of it? So once off, I have already explained a bit of it. Lower the cost and scalability. It reduces the server operations and maintenance pay-per-request pricing model. So you don't have to worry about the server maintenance or operations, or it allocates the memory or CPU for the function, and scale is as needed ups and downs. The next one, high availability. So function is only going to active or become an execution mode when client-side request comes to it, or some event triggers it. Unless and until it just goes shutdown and remains in a shutdown mode for next start or next initiations. Next one, faster development and deployment. After we don't have to worry about the server operations or maintenance or anything, right? So developer can more focus on the writing a code rather than having to worry about like other stuff. Like it was happening before. Like if any developer like starts like like a 10 years ago or 15 years ago, they know this, like how this was working, right? You might have like a 1 week of the, you build an app, you tested it, you will have like a month of the releasing of the app, like just a deployment, building infrastructure, or having a infrastructure ready for the production release. So this is like whole monolithic strategy of the application is gone by with the implement this serverless fundamentals. You just need to deploy your code your function, have it deploy it on your server with the any of the pipeline feature, like any of the pipeline provided, right? You can use any of the CI/CD tool, and then deploy it, and just okay, you don't have to do anything. Next one. So focus on the business needs. Like without having a work to do, now developer can more focus on the business logic. It can provide a more business feature than it used to provide in a 10 years or 15 years ago or 5 years ago. You can more focus on the agile principles. It really fits with the serverless architecture, the agile methodology. Like you will be able to more successful, more follow the agile with the serverless architecture follow-ups. The next one is reduce the expense on human resources. Like basically in the team, in the past, it used to have it like, okay, I have an infrastructure team, I have a DevOps engineer, I have another specific team for the hardwares, like to manage the servers, right? There is a scenario like there is a team like infrastructure is different, then DB server team is DBAs or DB database administrations are different team. Then you have to actually, when you do a release, you need to combine these all teams and then come up with the dates or manage the schedules and then maintain the servers or something like that. And you need to think about the other server patching in the past. But now you don't have to do, because there are no servers to manage. There are no engineers to maintain those services or anything. So it's gonna be like reduce your expenses on human resource and buying a specific hardware or maintaining those hardwares. What is the AWS Lambda? So AWS Lambda is the serverless computing services, runs a code in response of event or automatically manage underlying compute resources for user. User can use AWS Lambda to extend other AWS services, custom logics, or creates your own backend. Companies doesn't have to, or organizations doesn't have to manage any of thing. They just build up their architecture or their code, and then they will just mention the resources they're going to use, and that's it. They can just pay as per they gonna use the resources. Let's say in the AWS, you don't have to pay actively for the resources, but you pay the time your AWS Lambda function execution. So like it's a pay proportional to time, execution time, rather than have pay per resources. But it's both model is there. So it depends on which services or resources you are using from the AWS. The code that runs on the AWS is called Lambda Function. Like we often take a Lambda function as an AWS Lambda. No, AWS Lambda is a whole architecture. It's not just a function. It's a whole architecture that you are going to build for your application or your mobile application or for your services or for your batch queue or some things, the services. And sometimes you don't even write a Lambda function. You just use this architecture only, and then you just go for your, like if you are building a batch process, or if you're building something that is just, you are integrating with the few server resources and that's it, then you don't have to build a Lambda function. But for others, like if there are intermediary Lambda function is needed, like building web applications, building a backend for the mobile application development, building services inside for any batch processes or any job queues. building. There are other, like there is new edge computing, so you can build that as well. So this all services are offered, like the running code you write as a Lambda function, but the architecture itself, it's called AWS Lambda rather than just a Lambda function. The next, how this Lambda works. So once you write the code, or once you have it code written, you set up your code triggers from AWS services and HTTP endpoints or in-app activity from like any of the servers, mobile apps or a point, or there are much more rather than just explaining three. But then you deploy the code, and it will trigger based on the triggers or events you provided, and you are going to only pay the compute time you use. You're not going to pay or anything like extra for any if it's idle, your Lambda function is idle or your resources are idle, it doesn't count for those uh, expense. So the thing, like it's much more easier, you like the part from here, you don't have to, after the writing a code, you don't have to worry about any of the thing. You just have everything set up, and it just gives you the high availability for your applications. It does gives another thing like logs, or you have a notification queue, or which is a Amazon SNS, which is a notification services provided by Amazon. And you have let's say you have another stuff you can integrate. Let's say I wanted to integrate my AWS Lambda with my Google services. Like let's say I wanted to have an email automatically connect to my Gmail, and then this all are inbuilt. Yeah, it needs a little bit coding and the integration, but you don't, like after that it just runs by itself. Next, so as I have explained before, so what you can do with the AWS Lambda, the serverless web apps, build and deploy dynamic servers, or host a static web resources, or manage users, or it manages users or authentication to build the RESTful by itself backend processing. So all those serverless web apps you can build with the AWS Lambda and the help of the Lambda function. It doesn't need anything else. The second major scenario is the data processing. Let's say I have a use case where I wanted to process my data real time. It's from from one server to another server, or one S3 bucket to another S3 bucket. You can build those connections automatically with the right help of the Lambda function. The one of the major is like if you have serverless application model, basically a SAM application model application build, and you trigger your based on the trigger on the S3, and then you need a cloud formation. Like basically you this uh, put your resources there in the cloud formation. Okay, I need a S3 access, I need a SNS access, or I need a SNS, and you just give your IDs for those resources and the roles for the resources. With you don't have to even worry about the authentication or role providers or access or something. It has its own inbuilt role provider, which is IAM. And then you have to just what roles you needed, you just build it. Even in some of the, like when you're starting initially, if you have built a Lambda function and you're deploying, and if your access has a permission on it, it will create a role as well by itself based on the policy you have provided in your cloud formation script. Mobile backends, it's just not a mobile backends, you can build like UI on top of the backends as well. But the mobile backends, let's say I have a mobile app that needs to connect to various features like Gmail, or sending audio files, or sending pictures, sending GIF files. Those all backend services are built for using the Lambda. It just need, and then it just follows your development lifecycle for the front end clients. It's less complex and easy to develop, easy to maintain. And the edge computing with the new, this is the newest one, the Lambda Edge. it can easily runs across the different locations. Means, let's say I have an app which has to run only in North America and Europe, not in Asia or any other Asia Pacific region. Then I can just have that settings or scripts in my cloud formations, and it can have only those resources available for those regions only. Let's say I wanted to develop a globally, but I don't want to provide access for all the features to in the all the regions. You might have seen it in like in a specific in a AWS Amazon shopping websites, that you can't have access to few stuff in the few regions, or you only have things that are only available within your regions. So those are all those features are controlled by this edge computings, that it won't be available for all the AWS locations. It's gonna available only for few where you have mentioned it in your cloud formations. And it can respond very well. Let's say I have Lambda function which is running on the 3 regions. Like I have a US East 1, US East 2. So it means I have a 2 servers which I can use, or different user can use anytime, and it's available. The same application is available on both. So like anytime if the one of the server or one of the region is very busy, it can route your request to the another region by itself. So based on due to that, it can have a good user experience and highest availability or of your app. Now, understanding the Lambda, let's with the execution of the Lambda function. So I have it a couple of example here, which I'm gonna share with you. It's three example I have it, and then one of them one has like a Lambda AWS Lambda function with the package type image. The another has AWS Serverless function, which provides a API. And the third one is AWS Lambda function with S3 bucket event trigger to the Lambda function. So these 3 example, and there are much more. Basically, in a Lambda function, we call it Lambda, but there are inside the Lambda, there are couple of templates available that you can build, like you can say blueprints available for the building your code. Let me share my other screen. So once you have it, so here, let me just show how many templates you have it. This command will actually gets all the templates. So this is all blueprints. It provides for C# Lambda functions. There are much more for Node.js or Java or something, but we are going to talk specifically about the C# Lambda functions. So it has like even so basically Lambda empty functions. I have used this two for now, and the one serverless. But if I go to the separate task, like it has a core empty web app, the MVC web app or Angular or with the React and Redux as well, it creates a blueprint or like a empty code for you, and then you have to just put your business logic there. You can build it from scratch as well, but this is all available from the it's Amazon repo that they have it for template. So it builds, it's like once you have it, it creates a different the CS proj files or projects, and then you just put your code inside it and then go ahead. So these are the 3 main functions. Let me show how this function runs and what are the properties that we need to think about in the like when we talk about the Lambda, or how we develop it, how we do it in the like. So first I'm going to explain how it looks on an AWS console, and then we are going to slowly move from console to code, how it really works. So most of you who has worked with the AWS know this AWS Management Console, that it offers this all features when you have it, like when you have an account with it. So let me go to the first Lambda. So you can directly go to the Lambda functions, and then you have to do, so this is the 3 example I have prepared, and it has, so all of them 3, one has just a normal calculator demo, it's just addition, multiplication, and the subtraction, but it is as an API. The next one is S3 event demo, means my Lambda function is gonna trigger from my S3 bucket. Whenever the S3 bucket has a put object or create object or upload object or copy object operation, it's gonna trigger my Lambda function, and it's gonna do its own operation, and then returns back the response to the S3 bucket. Then 3 has a third one is the S3 bucket demo, but it's actually not a S3 bucket, but it just a S3 bucket is gonna hold the zip file package, and then it's a not a Lambda function which gives a full name based on the first and last name. But that function is defined by like package type is image, rather than the other 2 is package as in zip folders. So how this whole thing works? So zip folder you will see on the S3 buckets. So when you deploy your Lambda function, you will see a Lambda function here deployed, and what runtime you are using it, when it's deployed, or what type of the package type you have selected. But the actual code is gonna lie here. So I have selected this bucket, and all the zip packages is under this. So this is for S3 event demo. The zip package is from those, like currently it's gonna point this one because this is the latest one, and it what you can do, like if I wanted to change, it can be changed as well. And then the calculator demo will have a zip file and the serverless templates. So basic, this is a Lambda function itself, but it just defined as an AWS serverless function. We can talk about more in the like next couple of minutes, but for now when the serverless function deployments happens, it deploys a zip folder, a zip file, and then it has a serverless template that can go as in same unique ID which is conjectured with that package. And the third one, for the image type of function, it doesn't go on S3, it goes to the Elastic container repository. So when you have a Lambda function deployment package type as an image, it doesn't store that image into S3, it stores that image into the ECR repo of under AWS. So if anytime in the future, if you are gonna find like where my image is, it's gonna under ECR, not an S3 bucket. But it does by itself with the like, just you have to mention the package type, it's image, or package type is zip. So zip is like by default, and then if you want to build your Docker image as a package type, then you have to mention its package type image. Let's go a bit in a Lambda function. So let me give, so this is a serverless function. So what is actually a difference between serverless and the Lambda? So major difference I would say is like, serverless function will have API gateway running with it. So basically you are allotting kind of a API server to it. It does manage your requests and responses, and the Lambda function layer is already integrated with the API gateway. And to do that, you don't have to mention anything. All you mention is like, my function is gonna run as an, my function is like a resource as in like AWS serverless function resource. And then with that it provides all the other features as well. When this is the normal code configuration or code details of the AWS function. So first of the code. So what is in here? It's a package size, how much the package size I have it. It's a zip file, so it's like 143 KB. and it attach. So when it zip it, it has a hash algorithm to it. It follows, and it has uniquely defined this with each package. So when you deploy, it does unique hash algorithms on it. Then what is my runtime? My runtime is like the function execution runtime environment, like, and not environment, a framework, or the languages that I'm going to use is .NET Core 3.1. This is a handler. So what is my first initiation point of the Lambda function is like, so this handler is like, so first of your folder name, when you create your project file in when you open a Visual Studio or Visual Studio Code, then you have it like folder name. Then second one is your namespace. Third one is your Lambda entry point, means your startup file. And the fourth one is your actual handler, where your code, your written code is gonna start execution, or it's gonna you can write a code inside that function handlers. So for these handlers are different for these two structures, like one for serverless structures and the other one is Lambda functions. So I'll show you in the next when we go in the VS Code. Then it has a different layer version. So you can, if you have a versioning enabled, it can have a like, okay, version 1.0.3, version 2, and then you can have a different ARNs for those different versions. So now you have deployed it, you wanted to test it, so you test the Lambda. This is called Lambda Test Console. They provide it inbuilt, but I would suggest, like, to test a serverless function or APIs that you have built, use a Postman or any other another API testing tool rather than testing here, because it gives a response, but it just like, it's a better control, or like visualize it's a user experience, it's better than this one, because you see all the logs and everything here in one, rather than having on a different response. Monitoring a Lambda function, this gives you metrics, logs, traces, like how much time or invocation happened for my Lambda action, duration of it, error counts or success rates, or the async delivery failures or iterator aids, or concurrency executions, like parallel executions. If I my Lambda running for 5 requests, okay, it's gonna run 5 concurrent executions, or 2 concurrent, and then it finished 2, and then starts another 3. Like that. Basically, it's a metrics, provides a dashboard that how healthy your application, or how's the health of your AWS Lambda. The logs. So when you deploy log functions, it automatically provides a CloudWatch permission on it. So you don't have to go and, okay, I need a log group. Yeah, you can create a different log groups, but if you don't create it, it creates by its own. You don't have to worry about, okay, I have to create a log groups, and I have to go to integrate with the CloudWatch. Yeah, I have to go there. In the past, we have seen it, right? Like when web application, even I have done it. Like when we develop a web application, we need to have like another log or telemetry or any notification services to have a logs written there, or have a logs notified, or any failure notified that. But with this AWS Lambda, you don't have to do it. It just does everything by its own. Then stress is like, this is like a service map you can generate with your Lambda, and response time and timestamp, and you can see everything here. Like if you are writing it, currently it's not done, but you can see it. And it's a feature provided by Amazon X-Ray with the CloudWatch services. This is one of the most important like configurations for your Lambda functions. So general configuration is like description you provide for AWS your Lambda functions. The memory you wanted to allot to that function. Let's say I have a feature that will have an image on it, or that will have it has to save audio temporary or save image temporary. Then you need a more memory than to run your function than the normal ones. So you have a memory like until I think 1000 It's 1 gigabyte you can allot. Then the timeout, the Lambda function timeout is like from 0 to you can allot for 15 minutes. And then your Lambda function, like if it go beyond to Lambda, it does timeouts on the Lambda function execution. But it depends on what kind of a services you are building, or what kind of a web application you are, resource you are building it. Triggers. This is triggers is like basically from where your Lambda function is being called or invoke or thing. So currently I have, for this serverless, I have 2 triggers, which is one is called a proxy resource trigger, and the other one is the root resources. Most of the time you don't need this trigger unless you have it your unless you have a use of it. But the proxy resource trigger, it's more like we use it oftenly. Basically it's going to trigger, it's going to provide an API request and response. Permission, it's a IAM role permissions. So this role gives a permission of the authentications or different features. So if I go in the roles, what I kind of permissions I have it. So I have a permission for Lambda execution, Lambda basic execution, and full access. And if I have another permission, which is like a Lambda, like a S3 or ECR access or EC2 access or SNS access, so I can provide with the like attaching those policies inside here. Then destination. So destination means in the end of the Lambda function execution, if you provide any destination, another destination of your Lambda function responses or any notification services that you can provide. Environment variable. So like if we have any environment variable, let's say execution time or some other we are tracking it, we can provide it here. Tags is basically you give a tags to your versioning. So this is the how it does by its own. So like it has a stack ID in unique, it has a stack name, and what is the function logical ID is calculator, and the Lambda is created by, means it's a Lambda, it's a serverless function, and it's as a SAM model, means server application model. Then VPC is a virtual private cloud. So I don't want to give an access to any other users. So I can create, or it should trigger within this virtual private network only. Then I have a VPC configured here. It gives like it isolates your function from being it available public, or being available into like accessible from your AWS resources. Monitoring and operation tool, as we see on the monitor and active resources, the traces and the monitor, the logs, the concurrencies. This is one of the moments. So it has function concurrency. So it does use the unreserved concurrency, and then it will have another reserved concurrency which can be used when your function running for multiple users or for multiple requests. Then it will use that, it hits that a peak that okay, now it has to use that reserved concurrency up from it. Then it allows that scale ups from the reserved concurrency, and it allows the executions. Then asynchronous invocation. So like maximum age of event like 6 hours. So if I have a asynchronous, then it should run for 6 hours, or that is the age of one event. The retry attempts you can configure like 0 to 2, or it depends on that. And dead letter queue services, it's like there is currently nothing, but you can provide your own configuration if you have it. Then this code signing and database proxies. If you wanted to use any database or any DynamoDB, then you can have it proxied here. File systems, if you are using any of the file system from AWS services. And the state machines. The state machines are basically a step functions, which you can, if your Lambda function is invoked from the step functions, then you will have that state machines mentioned here or put it here, like, and then basically step function does the orchestrate, like, okay, step by step of function invocations. It's basically a orchestrations tool. aliases, if you have any aliases for your function or any other, like you using this function with a different name, then it will, you can provide it here, and you can use the same name when integrating with the all other versions. Then versioning, it's not available, but you can enable the versioning on your code, and when you publish new versions, it follows that pattern, and then have a versioned AWS Func code. Then let's go to another function which has a trigger on it. It's the same. And so this is like how, so this function is gonna have a trigger from S3 to event demo. And then it's gonna trigger a function when it's have any object puts in a S3, and then it's gonna trigger this function. And if I go here in a configuration, it will have a triggers mentioned here from S3. So which bucket is trigger is imaging original TDC demo, sorry, trigger. So if I go here from the TDC demo, when I upload these images, it's gonna trigger the Lambda function. What Lambda function does, it resizes the images, puts the watermark on it, it does grayscale of the image, and then it just upload backs that image into the destination bucket. So destination bucket is transformation. So you can see that I have two images, which is grayscaled and resized here after executing Lambda. And if we go and check the CloudWatch logs for this one, we can see a different logs there. Let me go from here. So this is the all three CloudWatch logs for the all three applications or Lambda functions. So this is how it writes the logs. So when it executes, it has a unique request ID, and this request ID you can track it, and then it will do your all the things and then finish it, and you can come response it to your API. And this is for the serverless applications cloud logs, and then I will show you the S3 bucket logs. So this is how it triggers. So this is, I just used it. So this is how it logs. So Amazon, so it logs from where it has been triggered, and then this is all I have put it in the function, and then it just convert image uploaded successfully after conversion. So this is, you can mention your own log pattern, or this is, I have just for the demo purposes, but you can mention a couple of things here. You can have a dashboard on it. And then I go, so now the one thing I will show the ECR repo. For the image type of it. So earlier I mentioned, right, we have a function which runs package type is image. So you can see that image is being uploaded here with the latest tag. So when you tag the image, so the first tag goes here, the second tag is the latest. So don't use this two, use the latest one only. You can tag it a different way, but this is like a most basic way to tag the image, and it will have the URI in the demo in the function to point that code in here, and this all it does by its own. So now let's go to this Visual Studio Code. So I mentioned, right, Visual Studio Code, this is kind of image right now, and what it does, so for the image you provide the Docker host build output directory from where you need to take your package or DLL files. The image command is same as your handler, and the main important is handler here, because the handler is gonna execute when your Lambda invocation happens. So it will have a class and then your method name. And if you change a class name or method name, you have to change here in a Docker file, not in a Docker file, sorry, in a here. And this is the function role you can mention that you wanted to provide, or either you go manually apply it. The memory size we see there, it's it comes from here. And the function timeout means function running execution time. And the package type, this is when you have a deployment running as a package type, you have to mention package type image. If you don't mention, by default it takes as a zip file. And then what region you wanted to deploy, or what profile you wanted to use it, and configuration type. So this is the for the Lambda function with the image type as a package type. So, and then let me show you quickly at the serverless one. So in the serverless, there are three things are major. It's this for the deployment. So you mentioned the S3 bucket name, frameworks, configuration, and the same thing. Runtimes, it's here, and the function handlers. Then you will have functions. So for serverless, you will have the functions and the other classes you wanted to provide, but it will as an S3 event. So it creates this and it records that S3 event, the put objects and everything, and then does its a thing. And then the last one is the serverless one, this one. So serverless is like, as I mentioned, serverless templates. So this proxy resources and the root resources you mentioned here, and the type of the function is serverless function rather than having a AWS Lambda function. Those two type were the AWS Lambda function. Same default JSON here, but here we mentioned the stack, the prefix where I wanted to go, and the template I wanted to use for different resources. So here I can mention the VPC or gateway. This will create an API gateway, and it will have it VPC. You can have a parameter here, or you can have a SNS configuration here too. And all it does, it deploys and builds a zip package and deploys it. Let's go back to the presentation. Next one. Then when S3, so this is the example I give it, one S3. So what it's like user uploads the image to S3 and it's does the event and operations into the Lambda, and then it uploads back to the target bucket that we have seen as a code, right? There are limitations of the AWS Lambda. Like these are, I won't say it's a limitation, it's the architecture, it's a kind of a solution that is built that way. Those are hard limitations. So like disk space is like 500, memory can vary from 120 MB to 3 gigs. Execution timeout for Lambda function is 15 minutes, but if you have a serverless function, it's a API gateway, then it's a 29 seconds only. So your request can run only 29 seconds, and then it's gonna time out and give you the timeout error. Package type, you might have a like 250 MB deployment package will be 250 MB up to 250 MB. And there are soft limitations as well, which is still in a build from the AWS side. For the synchronous event, is gonna be maximum payload is 6 MB, while for the asynchronous invocation, the payload can be 256 KB. But as I mentioned, it's not an actual limitation, it's the defined principles of the Lambda services, for the serverless services to manage, give you a better end user responses. If your Lambda function is running for hours, this is our solutions for the few of the limitations. Like if your Lambda function is running for hours, it should be moved to the Elastic Beanstalk or EC2 rather than having a Lambda. If the deployment package jar or zip is greater than 50 MB size, it should be broken down into the multiple packages and the function. Let's say I have one Lambda function which is like more than 50 MB files. Like I have too much third-party libraries or NuGet packages. Then it should broken down in two Lambda function rather than having a whole big Lambda function running as on one. It's good to have a multiple Lambda layers rather than having a one big Lambda layer and executing it. If the request payload exceeds from the limits, you should break them up into multiple request endpoints rather than having a one endpoint and use it as an integrations, as in wrapping the another Lambda around it. And these are the real world AWS Lambda user, like CI&T use it, is it's running, and it's doing a wonderful giving a wonderful responses for the serverless, like what they have built it or what we have built it. Then other is Netflix. You have seen this a lot. Netflix is one of the biggest AWS Lambda function users, serverless technology users. And then there is a local Lytics. It's actually it's an analytical tool. It does different analysis around, and it's a startup actually. And the RIA Group, it's an Australian-based real estate application which does Lambda, AWS Lambda or serverless as a backend. Thanks a lot, guys.